Let me start by praying, and then we'll do some fellowship, and then we'll get into this. All right, my wife is here, so now I can begin. Didn't mean to embarrass you. Heavenly Father, we thank you for this opportunity where we can come together in this place. God, I just pray your special blessing over all the teachers and volunteers who are volunteering their time tonight to just serve your kingdom, God. And so we pray a blessing over them. God, right now I pray that by the time we finish this tonight, we'll be closer to truth than when we started. And so, God, I pray that you just give us minds to think through this clearly. I pray that you would make my words articulate so that everyone can understand. I pray all this in your name. Amen. So let's begin by doing a little review. Who remembers what we talked about last week? We looked at a number of the evidences offered in favor of the theory of evolution. Can anyone recall one of those evidences? Just yell it out. Wow. Something about DNA? You guys need my help. You guys need a lifeline. You're going to phone a friend. What? Finch Beaks? That was actually 2 weeks ago. All right, I'm going to help you. Fossils? Yeah, we talked about the fossil record. Specifically, we looked at the Cambrian explosion. Remember all of those animal body plans that just kind of show up in that particular rock layer, the Cambrian rock layer. And we said there really isn't any evidence of missing links or transitional forms to lead up to that. But we did talk about dinosaurs in the Q&A. And that was fun. Yeah? Yeah, we talked about Richard Lenski's experiment, which is essentially, it's not a computer program, it's like the real deal. He's studying E. coli bacteria. He's looking at, started in 1988, and it's still going on today, but as of 2010, he had 50,000 generations of E. coli bacteria. 50,000 generations. If you made that equivalent to human generations, it would be about 1 million years worth of evolution. Okay? And we said that in that length of time, in that number of generations, 50,000 generations, he saw that they could metabolize citrate. But we said they could do it anyways. It didn't actually evolve that ability. Essentially, a transporter broke so that it was on all the time, like the nightlight being on all the time. And so they also got bigger, and we said they lost their flagella, their tail, and that is supposed to be, the proof of evolution. I said, that's a de-evolution. That's not going to get you where you need to go. So that was Lenski's experiment. That's an important thing to know, I think, in this whole discussion. In fact, someone emailed me and said, I was watching this video online, and people were debating back and forth. I don't like to get into those things, because they don't usually go anywhere, but especially on YouTube. But someone brought up Lenski's experiment, and they said now they knew what the person was talking about. What else? Embryology. That was, Darwin said that was second to none in importance. He said that it was the strongest evidence in favor of his theory. It's still in the textbooks, but I showed that actually it's not true. In fact, Ernst Haeckel fraudulently drew these diagrams. They don't actually look anything like that. And they talk about the tail. We looked at all that. In fact, that was on the University of Berkeley website. They have an Evolution 101 site, and it was still on there. The embryos, it had the gill slits, and there was a whole blurb about how that was us kind of recapitulating our fish stage, of our evolution. So, ontogeny, although I watched the video, I said ontology, that's the study of being. That's what philosophers like to talk about. Actually, I'm taking a class called metaphysics, and we're getting into that. Ontogeny is this development from embryo to adult form. Okay, so ontogeny recapitulates phylogeny, is what the catchphrase. Know that for parties. Anything else? What else have we looked at? We looked at the, with the fossils, whale evolution. And I didn't critique all the different transitions. I said it has to happen in a very short amount of time. Even if it is millions of years, it's still too short to get all that needs to be accomplished done. The tetrapod evolution, I said they basically have to start all over with that since they found these fossil tracks. Yeah. Coelacanth, yeah, stasis. When you look at the fossil record, it seems like there's more stasis than actual evolution. Things remain the same for millions of years. And there should be billions of transitional forms in the fossil record. Okay? And Darwin said that was one of the gravest objections against his own theory, was that there just isn't these fossils. But he said, wait and see, we'll find them. And here we are, 150 years later, and we just don't have all of those fossils. What else? Vestigial organs, non-functional structures. Specifically, I looked at pseudogenes, and we said, and Francis Collins, he thinks that's a very persuasive argument. Chimpanzee has the gulo pseudogene, the broken gene for synthesizing vitamin C. Humans have it. So look, aren't we related? Isn't this strong evidence that apes and humans have a common ancestor that broke the gene? And I said, yeah, but if you look over here, guinea pigs have the exact same gene that is broken. Okay? So we talked about pseudogenes and vestigial organs. Just because something is non-functional now doesn't mean that it wasn't designed before. We know it had a function. Everyone agrees it had a function. And so why couldn't we just say that it was created with a function and then soon went non-functional? Kind of like the screen going non-functional on us here. Another powerful argument is homology, and that is you look at all these structures, they seem to be the same, and like the whale flipper and the bat wing and the human hand, and all of those structures, even though different function, the structures are very similar. And so maybe that points to a common ancestor. Listen, that's a pretty powerful argument. I readily agree that that's a pretty powerful argument. And I didn't stress this enough. They say that's common descent. That's because those all come from a common ancestor. But that also could be common design, right? Like, it's not just common descent is the only option. There's this idea, it's a common designer who made all of those things, so why can't we say that, the guy who designed the Porsche is also the guy who designed the Volkswagen Beetle. And if you look at the similar mid-rear engine and some of those other features, they're the same. And the reason they're the same is because of the common designer. Okay? And then I talked about junk DNA. Oh, we're back on. Perfect. Can I get that one on too? Junk DNA. There's all this junk in our DNA. And I said that it's not really junk. In fact, we know it's regulating things. And the ENCODE project in 2010 came out with all this information showing that, hey, this is not junk. It doesn't code for proteins, but it is doing something. So let's get into this. I've stalled long enough. So here's a couple of things you need to know. Bad arguments. There's some arguments that we should not be using, okay? And I had to throw these in because I don't want you using them. Okay, so please, if you're talking with someone who holds to the theory of evolution, don't tell them that evolution is only a theory, okay? If you're talking to an intelligent person, they will chew you up and spit you out, okay? Because the theory of evolution, or a theory, is a set of beliefs, but it's a set of beliefs that has been verified or repeated or tested. It has a lot of evidence to back it up. That's how science defines theory. Now, so you have things like cell theory, atomic theory, the theory of relativity, or general relativity, gravitational theory, the theory of evolution. Now, they're all considered scientific theories. Now, we can argue or debate whether it should be classified as a theory, but the fact that most people accept it as a theory, don't use this, it's only a theory. Because what they'll say is, and there's a bumper sticker, yeah, evolution's only a theory, kind of like gravity, right? And does anyone really want to question? Does anyone want to say, well, gravity is really only a theory? Or heliocentrism is only a theory? We don't want to use that argument, okay? So just avoid that. Another argument is, bad argument, is if we evolved from apes, why are there still apes? Right? It may sound like a reasonable question, but if you understand evolution, it's really not reasonable. If an evolutionist should respond like this, I don't know if you can see it on there, if God made man from the dust of the earth, why is there still dust? Right? And their response would be, well, you didn't use all the dust, right? And put that into Adam. Just like they don't believe that all the ape-like ancestors evolved into humans. A group broke off, okay? Think of the tree. Broke off from to one branch and evolved into humans. And that's why there's still apes, okay? And so don't ask them, and someone thought it was clever at this Baptist church to put that on the sign, and they just look like idiots. So you have something like, you have like this tree, right? And what the textbook argument is that we evolved from something like a hominid, okay? And so this hominid, that red dot there that you don't actually see a picture of, you're going to have chimpanzees breaking off one way and then eventually you get human beings, okay? And that's why there's still apes around on the theory, okay? So those are called bad arguments. I could probably do a whole thing on bad arguments, but those two just came to my mind. You hear quite a bit. So now that we've critiqued evolution, what I want to do is give a positive argument for design. So there is good reasons to believe that God supernaturally created. In fact, in Genesis it says, let there be, let there be, let there be, and it was so, okay? God creates by fiat or divine decree, okay? And so it turns out that most people actually will agree with you that things appear designed, okay? You don't have to necessarily push them to argue that there is at least appearance of design. Professor Richard Lewontin, he's a Harvard geneticist, he said that living things appear to have been carefully and artfully designed. Richard Dawkins, of all people, page 1 of The Blind Watchmaker, says, biology is the study of complex things that appear to have been designed for a purpose. Richard Dawkins agrees there is at least appearance of design. I already quoted from Francisco Ayala. In the first part there, he says, the functional design of organisms and their features would seem to argue for the existence of a designer. Okay? It seems that way. And so what is it about this appearance? Well, and I also showed you this slide. I thought I'd just revisit this. Remember, the atheist says, appears designed, not really designed. The theistic evolutionist, strangely enough, says that things appear undesigned, and that's why they argue junk DNA, pseudogenes, those kinds of things. But they really are designed, and I said that kind of they're both right. The Apostle Paul makes the argument that they appear designed because they really are designed. For since the creation of the world, God's invisible qualities, his eternal power, divine nature, have been clearly seen, pure design, being understood by what has been made, because they really are designed. And so here's a little illustration to kind of help with this whole thing. The difference between real design and apparent design. So here are 4 different kind of rock formations. Group 1. If you drive across the Black Hills of South Dakota, you're going to come across this particular formation. What's it called? Mount Rushmore, okay? And this is carved into the mountain is the likeness of 4 U.S. presidents. No one would argue that that is not the product of intelligence, okay? If you look at group number 4 is the Grand Canyon, okay? It's also a rock formation, but you're not going to find many people are going to say that's designed, intelligently designed, okay? The Grand Canyon seems to be formed either by a slow and gradual process, like Colorado River one sand grain at a time cutting through it. that's an unintelligent process, or over a short period of time with a lot of water cutting through the canyon, okay? And so either way, it's not intelligently designed. But then you have these other two categories. Group 2, I don't know if you guys know what that is. That's called the old man in the mountain. Now, I don't know if you can see this. It kind of looks like an old man's face. There's the nose, there's the mouth. It just kind of jets out from the mountain there. Well, this is in the White Mountains of New Hampshire. And it's actually no longer there. They tried to preserve it. It actually just completely, through erosion, wind, everything else, it just collapsed. So it's gone now. We have this picture to remember it. But that looks designed to some extent, but we know it really isn't, okay? And then finally we have group 3, which is, you can imagine a pile of rocks, and you find this crude-looking arrowhead, and even though it may look like an ordinary rock when it's with a bunch of rocks, although you can kind of tell there, you wouldn't fool an archaeologist. Someone who knew their stuff would say that's really designed, even though it might look undesigned. So we have 4 categories, okay? Group 1, appear designed, really designed. Group 2, appear designed, not designed. Group 3, appears undesigned but is designed. And then group 4, which is appears undesigned and really isn't designed. So as we've seen, most biologists, even staunch atheists like Richard Dawkins, agree that biology studies organisms that appear designed. So the question is there a way for biologists to determine whether or not an organism is really designed? Kind of like we can determine whether a rock formation is really designed. So really what we're talking about is these two. Is it apparent design or real design? Now, we talked about this in the other series we did. I talked about how some conclusions are excluded from being reached because they're considered not scientific. It's called methodological naturalism. You can't come to a supernatural conclusion. You must come to a natural conclusion. And so what they'll say is, so you want to say that things in biology come from an intelligent designer? Well, that sounds like God, so no, that's not science. And they'll exclude it. And so really there's only one thing left, what Richard Dawkins says. Things appear designed, but there is no design really there, okay? And so where you'll see this thing is like Francis Crick, remember he co-discovered the DNA double helix structure. He said that biologists, they must constantly keep in mind that what they see is not designed, but rather evolved. Okay, it's like you look at something, it looks designed, but just remember that's evolved. And this over here, it's evolved. Okay, and you hear there's other quotes. Scott Todd, he's an immunologist at Kansas State University, says even if all the data point to an intelligent designer, such a hypothesis is excluded from science because it's not naturalistic. David Watson, who's gone now, but he's professor of zoology and comparative anatomy at the University College London. He says evolution is a theory universally accepted not because it can be proven by logically coherent evidence to be true, but because the only alternative, special creation, is clearly incredible. Not like incredibly like great, like it's just incredible, okay? And so design theorists have come up with a better way. Instead of excluding one of the possible options before you even come to the data, what they do is they'll follow the evidence where it leads. And if it leads to a supernatural conclusion, so be it. If it leads to a natural conclusion, so be it. Okay? And so we're going to keep our minds open to the possibility of design in nature. There's 2 things that they look at. 2 positive tests for design. One's irreducible complexity, one's specified complexity. But just for fun, before we get to like the hardcore arguments, I thought I would give you some more fun arguments that I normally give to kids, okay? But I think you guys are probably bright enough to handle it too. So let's just look at some of these. I think you'll find these kind of interesting as well, okay? So let's start with some designed creatures. Let's start with the giraffe. That guy's missing some stuff. Like muscles and skin and everything else. But the male bull giraffe actually is about 18 feet tall. Which zoo did we go to at the church on Elmville? And they had a couple giraffes. I won't tell that story, but they shouldn't be in captivity. So they were 18 feet tall. The neck is about 8 feet tall. And so here we have a picture of the heart. See, the giraffe is a really cool creature, but it has this long neck. And to get blood from its heart to its brain, it needs this huge pump. And I'm not trying to gross you out, but that's a picture of a giraffe heart, okay? They're about 10 kilograms or 22 pounds. They're about 60 centimeters tall, so essentially the size of my daughter. And so she's a little bigger than that now, but she used to be that size. I kind of miss that. So you got to get blood up the neck. Now you're thinking, well, what does this have to do with design? Well, when this guy goes to put his head down, there's a big problem. Because your heart doesn't stop pumping when you move around, okay? And so it keeps going. He has to pump the blood up to his brain. He's fighting against gravity, right? Now he puts his head down. Gravity's fine. The blood's going to flow down. There's actually enough pressure from the heart of a bull giraffe to blow his brains out. Literally cause a brain aneurysm, okay? And so this guy's got a huge problem. He just wanted to take a drink, but now he's dead. And while he's dead, he's thinking about, well, man, I wish I had evolved something to stop this from happening as he's being eaten by a lion. No, dead things don't evolve. This guy actually doesn't die. This is really cool. In the arteries of his neck, and this says that these valves actually don't exist in, as far as I know, any other creature's arteries. We have these valves in our veins. In fact, when you have, so blood leaves your heart, it's oxygenated, it gives the oxygen to your cells, and then it travels back to your heart through the veins. I don't know if you guys know this, but in your legs, you have these veins and these valves that actually stop the blood from pooling down in your ankles. And as it goes between the muscles, as you move your muscles, it actually helps move the blood back up to your heart, which is kind of cool. And so those guys who stand at attention for like long periods of time outside like the palace, they actually they're trained to actually rock on their heels, keep the muscles moving. And I don't know if you see this you can look it up on YouTube. You actually see some of these guys like pass out because the blood's not circulating. They need to keep their legs moving so the blood doesn't pool. It's very, very cool. And then when those valves break, it actually can cause the veins to kind of get bigger and, what do they call those veins? Yeah, varicose veins. You don't like those. So what we're talking about here, this guy's got blood rushing to his brain. Luckily for him, he's got valves that literally shut down as he turns his head down. That's kind of cool, right? But it turns out there's actually enough blood pressure past the last valve to go to his brain to kill him, okay? There's enough pressure there still to kill him. Luckily for the giraffe, he actually has I call it a sponge for kids. It's actually a network of capillaries, like very small blood vessels, that you could call a sponge, and they actually absorb all that blood at the base of the brain. So this guy's fine. He's still getting blood to his brain, but not at the amount that he would have if he didn't have this system. But here's the problem. This guy looks over there, sees the giraffes. You guys are cool. He sees the antelopes. I think antelopes are out there. And you're okay, guys. But he looks over there and he sees a lion. And scientists don't really know how instinctively they just know the difference between the two. Like, you're my friend, but you're not. They just seem to know that right away. No one has to teach them that. And so here we have this lion. He's going to come. Okay, so we're drinking. And what do? Well, if you're a giraffe, you can actually take on the lion. The kick from a giraffe can actually kill a lion. Do you guys know that? But most of the times they don't stick around and see if that works. So so he throws his head up. Does anyone see a big problem? Going from 0 to 18 feet elevation. Anyone got it up really quick? And then you pass out really quick. Your body literally throws itself on the ground so that you can get blood to your brain. It's pretty cool. Passing out is actually kind of a good mechanism. But he throws his head up. Now he needs blood to his brain instantly. Okay? And this is really cool. Those valves open. Oh, that's our passed out giraffe. He's actually sleeping. This guy runs off, he's fine, and that's because the sponge, literally those capillaries, go right to the brain, release the blood right to the brain. There's enough there, and then obviously the valves open and you can get blood going to the brain. It's fine. Very cool. Now, is the case closed argument? No, but I think it's pretty wild. Here's another creature that I think is cool. The incubator bird, because I really like chickens. No. This is sometimes called the brush turkey. It's a very unique bird. It's the only bird that doesn't sit on their eggs, okay, to keep them warm. This bird actually builds a giant mound. Yes, I said a mound. Where is he? Oh yeah, there's his mound. So what happens is the female introduces herself to a number of male birds, and to see which male she's going to choose, she checks out their mound. Okay, which is pretty cool. So goes over, I don't like your mound, you got a good mound. So they get married and start laying eggs, and so the female starts laying these eggs, and once she's done laying her eggs, she's gone. Just takes off, okay? And she leaves daddy bird to look after the eggs. Now here's the problem. These mounds have to be the eggs have to be just at just the right temperature. In fact, the eggs have to be at, I don't know if I got this on here. Yeah, here we go. Exactly 91 degrees Fahrenheit or 33 degrees Celsius. Exactly. Literally, if you go 1 degree above that and 1 degree below it, the birds and the eggs die. Okay? So all the incubator birds carry digital thermometers with them. You guys don't believe me? High-tech stuff. What they actually have, and scientists actually don't know precisely what's going on here. Either in the tongue or in the beak of the bird, they're able to tell the difference within 1/10 of a degree. So 91.1, 91.2. As the temperature goes up, daddy bird has to figure something out. This mound can't get too hot. So he might cover the mound with more sand to reflect sunlight. He may dig down and, he has to, every time he digs down, he actually is getting oxygen to the egg, so that's really important. But he has to keep it just the right temperature. Now, who taught him that? Right? Like, how does he know? In fact, when the eggs are hatched, they're buried alive, the chicks. They literally just start scratching their way out and shake the stuff off and scratch their way out. All the male birds leave. They don't stick around to get advice from dad. They leave, and now they're going to go next year, build their own mound, and do the exact same thing for their chicks. And nobody told them how to do it. Okay? It's pretty cool. It also has to be at 99.5 degrees Fahrenheit, which is interesting. I think that's pretty cool. I don't think that process evolved over time. In fact, you get it wrong, it's over. Okay? There's no natural selection if you don't produce offspring. Okay? If your offspring are dead in a mound. So, I just like saying the word mound, if you didn't notice. The archerfish. This guy, I use him when I teach grade 11 physics, because this guy knows more physics than my students. The archerfish is a very cool fish. Let me show you the archerfish.
While some use vicious weapons to dispatch prey, others employ the finesse of a marksman. The archerfish uses a water pistol. It makes a gun barrel by pressing its tongue against a groove in its mouth. It closes its gills to force out the water. It's accurate up to 2 meters.
Slow-mo. All right, that's lunch. You can actually see those at the new aquarium in Toronto. It's kind of cool. So a couple things these guys do that are really remarkable. First is they take into account refraction, which is Snell's law. Let me show you what I mean. I used to teach this in grade 10. And anyways, so when he looks at the bug, what he thinks is the bug, it really isn't the bug, because you and I know that light actually bends when it goes from 2 different media. And so it goes from air to water, it actually bends towards the normal, we say, and so it looks something like this. The actual bug's down there, but to his eyes, he's going to see it up there, okay? Which is kind of, it's like if you've ever taken a spoon and put it in water, you can see it looks bent. So he's got to take into account Snell's law, and not to mention the trajectory of the stream. Listen, if I'm going to throw you a football pass and you're over there, I got to throw it up and curve through gravity to get to you. I can't just go right at you. So I thought that's pretty cool, because I teach gravity and refraction, so that's kind of neat. He seems like a pretty cool creature. This guy, though, he takes the cake. The bombardier beetle. Named after the bomber crew of the U.S. Air Force responsible for sighting and releasing bombs. This guy has the ultimate defense mechanism, okay? Like tear gas meets a Tommy gun. Oh yeah, video. You guys like videos, right? Don't mess with this guy.
But the master of chemical warfare is the bombardier beetle. It can create a chemical reaction within its body so violent that boiling caustic liquid explodes under its abdomen.
Love the sound effects.
By pulsing the jet 500 times a second, it keeps its rear end just cool enough to prevent it being caught.
They study this creature in advances for jet propulsion, okay? So he's made it there. But what's going on with this guy? How did he evolve to be so cool? Well, he's got a couple things going on there. First, he has these 2 chemicals, hydroquinone and hydrogen peroxide. Both those things have to be separate. They come together, they actually react together. Okay, so you've got to evolve those separately. And then we're going to have them mix together, okay? And when they mix together, remember, they react. So we have an inhibitor that's with them. That's the second step. And then when you go from the second step, now that we've got these things together, we want them to really react. And so you throw in a catalyst. So another chemical, catalyst with these 2 other chemicals, when they come together in what they call an explosion chamber, this area right here, that's the explosion chamber. These things react together and explode out. And then he's got these 2, you call them gun barrels if you want, and he can shoot essentially like 360 degrees around himself, except for over top of himself, he can shoot everywhere else, okay? And so, I think I might explode these, yeah, there they go. So, that's what's going on there. Listen, think about this. Let's say you evolve the chemicals, the catalysts, it's all good, but you don't have the explosion chamber. It's literally over 100 degrees Celsius. That's just the temperature. Extreme pressure. You saw it just explode out. Literally, it's like flash vaporizing as it comes out of his abdomen. Okay? So no explosion chamber. Well, then you've got a problem because this guy blows himself up. Not only that, Okay, let's say you've got the explosion chamber, you've got the two chemicals evolved separately, you've got the catalyst, that's all good. But you don't have an exit hole. Right? The gun that actually is able to move around and shoot at things beside him and in front of him, you have a serious problem. You blow yourself up. Okay? And so this is like an argument for what we would call irreducible complexity. That is, these things have to be together. Remember, evolution has no forethought. It doesn't think about, hold on to that chemical, hold on to that chamber, hold on to that gun barrel, because we're going to need it someday. It doesn't work like that, okay? And so that's the bombardier beetle. The woodpecker, I'm just going to do maybe one more of these and move on. The woodpecker. There's a lot of cool things going on with the woodpecker, but it's mostly known for the fact that it smashed his head up against a tree for a living, right? So this guy's got there's a couple things going on here. It needs an industrial strength beak, an industrial strength skull, and this cartilage piece that goes in between. But let's say you're evolving this slow and gradual. So you get the industrial strength skull, but not the industrial strength beak. And you go to smash your head against a tree, and your beak just folds up like an accordion. Okay? Or shears off your face. Okay, I know how it works. It didn't work that way. It works industrial strength beak, but just a normal bird skull. What happens? Your beak goes right through your skull. Okay? It doesn't work that way. You got to have all of these components plus the shock absorber for this whole thing to work. In fact, scientists who are specializing in concussions are studying this bird to see how this whole thing plays out. The skull of a woodpecker is actually the thickest bone to body ratio of any organism, okay? Which is kind of neat. So this guy needs all of these components together. And not only that, once he's through the tree, what's he doing? He's drilling the tree because, what's he want out of the tree? Bugs. Most birds, their tongue ends at the end of their beak. Some of these guys have 10-inch tongues. Okay? So if you evolved all this other stuff but didn't have a 10-inch tongue, you'd be in trouble. So wait, he just sticks his tongue in the tree and the bugs just kind of jump on? Doesn't work like that. He actually has sticky glue that's on his tongue. So he sticks his tongue. Some of the tongues are barbed, so you can stick them like a Victor fishing or something, right? I was trying to listen to what you guys were saying. I knew what I was going to say. So he sticks the bug to his tongue, pulls his tongue back in his mouth. You see a problem? You now have something stuck to your tongue, and you're going to swallow it. He's going to swallow his tongue. No, he evolved an enzyme that digests the glue on his tongue so he can swallow the bug in on his tongue. Evolution thinks of everything. Yeah, I think this guy, just so you know, when he's smacking his head against the tree, scientists have figured out he has to open his eyes every time because the shear force, if he didn't hit the right spot, he would literally shear his beak right off his face. So every time he goes to hit, he opens his eyes, closes them. Oh yeah, you got to close your eyes. You want to know why? Because the force of him hitting his head against a tree is enough to actually pop his eyes out of his head. That's legit. They used to think it was because he didn't want wood chips in his eyes. Yeah, just didn't want the wood chips. Now they say, no, the force is so strong that literally he has to close his eyes so they don't pop out of his head. Okay? Look this stuff up. It's pretty cool. I like the woodpecker. This guy's not too bright, though. Check this out. Pretty strong, though. That's not a tree. So, you see what's going on there. Pretty strong. And this one, okay, I'll do this one really quick. Metamorphosis, you want to go from a caterpillar to a butterfly? Well, they actually go through this chrysalis stage. They literally make a cocoon for themselves, break down every single cell in their entire body, and then on the other end come out as a butterfly. Now you got to think about this. The butterfly is the only thing that reproduces. The caterpillar has no reproductive system. In fact, is that for me? I want pizza. I want pepperoni, double cheese. So what you have is Reproduction happens only at the butterfly stage. You got to get there. Remember, there's no forethought in evolution. So, for a creature to come to the point where it's going to break down, go through a programmed cell death of all of its cells, without knowing in advance where it's going, I mean, that's suicide, literally. The chrysalis would be essentially a coffin if you didn't know where you were going. So how does the process of metamorphosis evolve? I don't think anyone on the planet knows, okay? And there's some pretty smart guys doing research on this stuff. How this whole thing originated, I think it was designed. Then you could talk about it being like, caterpillar starts off crossing a bridge, doesn't know where he's going, and then ends up on the other side. But we got to keep going here. So irreducible complexity. Darwin himself said you could falsify evolution. In his book, he said, if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. So Michael Behe, author of Darwin's Black Box, the biochemist at Lehigh University, he believes he's done just that. He believes that he's identified systems, and we're going to look at one, biological structure that he calls irreducible complexity. He says the irreducible complex system is one composed of several well-matched interacting parts that contribute to the basic function, wherein the removal of one of the parts causes the system to effectively cease functioning. What does that mean? He says, think of it as a mousetrap. Okay? A mousetrap means all 5 parts, and you're going to catch the mouse. You take away one of the parts, like the platform or the catch, or the spring, or whatever, and the thing doesn't work properly. It doesn't catch mice. So that's his example of an irreducibly complex structure, okay? A mousetrap. But he found something in biology called the bacterial flagellum, okay? Which is essentially the tail of a bacteria. And when you look at it under electron microscope, it looks like an outboard motor, okay? Essentially, that's an electron microscope picture. There's just an animation. It has all these parts that seem to be just right. In fact, when they reverse engineer it and try and take away one of the parts, it doesn't function. Okay? So this little rotary engine goes at 100,000 RPM. Do you guys know how fast that is? 100,000 RPM. That's 1,600 revolutions in a second. It has 40 protein parts. And it has to be assembled in just the right sequence, okay? This is like the poster child for irreducible complexity. This is a nanoscopic machine. Like, people thought maybe things would get simpler as you go down at the nanoscopic level, like microscopic, and then down to the next level. Well, what we're seeing is things just get even more complex, okay? Now, there's been some criticism. Ken Miller, we talked about Ken Miller quite a bit. He's a theistic evolutionist. He's written the textbook. He says the type 3 secretory system, which is essentially a micro syringe, that has 10 of the protein parts. So the motor has 40. This one has 10 that are similar. So maybe the motor evolved from the syringe. Now this syringe is kind of nasty. It will poke itself into other cells and release this kind of nasty stuff that takes over parts of that cell. Turns out, there's a few things wrong with this picture. First of all, it only has 10, not 40. So he likes to think it's like an intermediate, right? Well, now the scientists are saying, actually, the motor came first and the syringe came second. So if anything, it's de-evolution. You haven't actually evolved anything. And was there anything else about this? Oh yeah, not only is all the parts have to be, remember, they make a big deal. 10 of those parts are in the syringe. Well, you guys know that if you take all the parts of a Honda outboard engine, put them in a sack and shake them around, that's not going to build anything. It turns out to actually build the bacterial flagellum requires DNA instruction, which itself seems to be irreducibly complex. And so Behe calls this irreducible complexity squared. Did I lose this? No, we're still good. I was told the batteries might go. Okay, so there's irreducible complexity, and then there's another argument called specified complexity. Let me explain specified complexity to you. like this. On my 30th birthday, my wife bought me a car. She didn't really. I wanted a car. She didn't buy me one. It's a sore spot in the house. So let's say she bought me a car and it had this license plate on it. Now the chances of me getting that license plate are pretty slim. In fact, the chances of me getting this license plate are like 1 in, I thought I had it on there. It's like 1 in, I'll come to it, I think. It's a really high improbability that I would get that license plate. But I can't conclude that that license plate was designed for me, right? But what if I got a license plate that said TIM 1983 for my 30th birthday, and that's the year I was born? And it's on my new car. Would it be reasonable for me to conclude that that is designed for me? Everyone said, yeah, of course. So there's something different than just complexity going on. There's something called specified complexity. And so our argument is not, whoa, look how complex that is. It's just way too complex. That's not the argument. The argument is there's complexity, yes, but there's something in addition to that. It's a pattern that's a specified pattern on the system. And so here we have specified complexity. Oh, here it is. So the chances of me getting the license plate are 1 in 176 million. Okay, that I get any license plate. But the fact that I got that license plate with my name on it the year I was born says, hey, that's designed. That's a design inference, okay? So that's how we can, keeping this idea in mind, we can, when we come to DNA, we'll show that, hey, we can actually infer design. This was in the movie Contact, the SETI program, you know, they got all the prime numbers came back in like a radio signal, okay? All the prime numbers, hey, that's a pattern. That's a specified pattern. Not only are those numbers complicated, really complicated, like, what is it? It's a really high number. 10 to the 308th power, but it's also specified. We know what the prime numbers are. But when you go to the DNA molecule, I mean, Bill Gates, this guy's not he's a computer guy, he's not a biologist, but he says DNA is like it's like a computer program, but far, far more advanced than any software ever created. An origin of life researcher says that the problem of the origin of life is clearly basically equivalent to the problem of the origin of biological information. What are these guys talking about? It turns out that just like our language, the English language, has a code system, we have these 26 letters in our code system, and then you can put them together to write messages to people, to communicate. So I put, the car was red and the car had 1 key. I use 3-letter words because in DNA, when you put 3 nucleotides together, bases, you actually get a codon, which codes for an amino acid. And amino acids code for proteins. Remember we talked about this before. And the protein eventually makes us. And so when you look at DNA, it has a language. It has a code system. It's not a 26-letter system. It's a 4-letter system, okay? GCAT. And when those letters are put together in pairs of 3, they form what we call codons. And those code for amino acids, and amino acids code for proteins. And so there's actually, it's not that these letters can be in any order. I mean, they really could be in any order. But the fact is, when we study them, they have to be in a certain order. So that arrangement of letters may just seem random to us, just as these letters may seem random to someone who doesn't speak English, but we know better. We know that those letters in the English language form sentences that mean something. And if you know something about DNA, you know that those letters in the right order code for amino acids, which code for proteins. Okay? So when you study the DNA molecule, you're actually seeing evidence for design. Specified complexity. Okay? Specified complexity. Now there's people come back at you when you promote something like a design inference. an intelligent designer. There's a few objections that might get thrown back at you. One is bad design. In fact, I watched a video today from Richard Dawkins, and he gave the whole video just about all the bad design in the world. And then evil design. What about those things? Well, let's talk about bad design first. I was in Cuba. And I don't know who set up the urinal. It was like this high. And Stacy's brother is a short guy, so it's funny. Yeah, some of these are bad. This, I don't know what button I pushed. Who puts it down above the... I don't know. Okay, bad design. How do we respond? Just because something is poorly designed doesn't mean it's not designed. But before you even get there, here's where I go with people. When someone says, well, what about the bad design? I say, first, that's not a scientific challenge or objection to what I'm saying. You're actually offering me a theological objection to my scientific case, okay? So normally I'll say to the critic, you know, if you'd like to talk about theology, I would love to talk theology with you. But I just gave you science. So if you'd like to respond, you know, with a scientific answer, then let's go there first. Okay, so when someone says bad design, they're not talking science, they're talking theology. They're making an argument against the designer, okay? Whereas the intelligent design movement, which is separate from creationism, the intelligent design movement doesn't necessarily say who the designer is, okay? Which may be one of the faults with the theory, or if you're just thinking in terms of science, it's probably one of the advantages of the theory, okay? And so, well, what do we say? Well, that car right there, I Googled the worst car ever built, and apparently the Gremlin is the worst car. People had said their doors were falling off while they were driving, and well, it's hideous. Apparently it's a rust bucket, gas guzzler. The back window would spontaneously break. Just a terrible car. But just because, you know, there are really well-designed cars like the 2012 Ferrari, okay? Just because we have some cars that are better designed than others doesn't mean that the Gremlin wasn't designed in the first place, okay? So the question is, what's the optimal design? I mean, the Ferrari is not the optimal design for a family of 6, okay? Maybe for a single guy, but it's not good for a family of 6. So does a car need to have maximum optimality to exhibit design? And the question is, well, who determines what's optimal? Is this Ferrari bulletproof? Is that going to be our scale? Or, you know, how heavy is it? Or anything like that. So, bad design. What about cruel design? Just because, now speaking just as someone arguing for an intelligent designer, cruel design doesn't necessarily mean no design, okay? Just because something is cruelly designed, here's the torture rack. That's a medieval torture rack. Would anyone conclude that just because this complex mechanism is not the product of an intelligent designer, because the design can't be a very good person? Let's just say designer. Because a designer can't be a very good person. I don't know if that question makes any sense. Let me translate it for you. Just because the rack seems like a morally cruel mechanism doesn't mean the person who designed it is a morally cruel designer, okay, or being. In fact, the person who designed it could be the nicest person in the world. We just can't make that leap, I don't think, okay? And so when you think of the atom bomb or something like that, was the person morally evil who created it? I don't know if we can say that just because it's the atomic bomb. But there's more that could be said. You have to take into account when you're talking with someone and they want to talk theology. Within my world, well, I believe there was a fall, and the fall changed some things about this world. And so if you want to talk about biological creatures like, you know, the lion or the shark or whatever, well, the fall might play in, depending on where you're coming from, how you talk about this idea of cruel design, okay? Or giving a defense for your designer, like a theodicy or something like that, okay? Trying to explain the problem of evil in the world. Now, it's interesting that the theistic evolutionists will point to their theory as being better at explaining evil in the world, okay? Because all this evil that we see in nature isn't attributed to a creator on their view, it's attributed to evolution, okay? So you creationists say God created the lion that rips everybody apart, or rips the zebra apart, or whatever. They say, no, evolution did it, but here's the problem. The theistic evolutionist believes that God created the process to begin with. So you haven't escaped the problem of evil by saying that evolution did it if you're a theistic evolutionist, because you actually believe that God created the process to begin with. Okay? So it maybe just pushes a step back one step. Okay? But I got 15 minutes here. I want to get to something to do with the theology. Okay? There's a lot that could be said. Remember, we're talking about should Christians embrace evolution. And there's a lot of theological reasons why I believe a Christian should not embrace molecules to man evolution. Some of those reasons, which I'm not going to get into, may be the order of events in Genesis. You know, whales on day 5. Well, evolution says, whales on day 5, mammals on day 6. Well, evolution has land mammals and then whales. Okay? Trees, day 3, and fish, day 6. Well, evolution says fish, then trees. You have birds, day 5, dinosaurs, day 6. Evolution says dinosaurs evolved, and then actually, dinosaurs are still around today. They're feeding your bird feeders, okay? They believe that a dinosaur truly is, a bird truly is a dinosaur, okay? And so the order of events is all wrong. I could point to Genesis 1:25, which says God made the wild animals according to their kind. In fact, it says the livestock according to their kind. All the creatures that move along the ground according to their kind. That according to their kind shows up quite a bit in just Genesis 1. And I think it's trying to tell us something, like these animals stay within their kind, they reproduce within their kind, and they don't turn into other kinds of animals. I think an argument can be made there as well. But in the time remaining, I want to focus on one major problem, which concerns the existence of Adam. So theistic evolutionists hold that humans evolved from an ape-like ancestor. Okay? As a result, they do not believe that Adam was a historical figure. So here's Carl Giberson. He was president of Evol6 at one time. I don't know if he still is. That's Francis Collins' theistic evolution organization. He says, in his book, Saving Darwin, the Genesis story of creation loses all contact with natural history and starts to look strangely like an old-fashioned fairy tale that might teach a lesson, but certainly makes no claims to historicity. I began to wonder how an old story about a guy named Man in a magical garden who had a mate named Woman made from one of his ribs could ever be mistaken as actual history. Dennis Lamoureux, brilliant guy, but really gets things wrong, I think, in his book Evolutionary Creation, says, my central conclusion in this book is clear. Adam never existed, and this fact has no impact whatsoever on fundamental beliefs of Christianity. Has no impact. Okay, we'll see. So did Adam really exist? Well, if you take the genealogies that are all over the Bible seriously, it seems like he did exist. Genesis 5 starts with Adam, talks about Adam. I'm not going to read all these. First Chronicles starts with Adam, Seth, Enosh, and keeps going. In fact, Enoch is the 7th from Adam, and in, I think it's Jude 1:14, says that Enoch was the 7th from Adam. And that's what we read, actually, in 1 Chronicles. In Luke, we see that Adam's in there. And then finally, there's the Jude reference. Okay? So, listen, you don't need a PhD in genetics to know that you, a biological organism, cannot be descended from a metaphor. Okay? Does everyone get that? Where exactly do the historical figures show up? Is it Abraham? Is Abraham a real guy? Or is that still the mythology? Is Moses real? Like, where exactly do the real people start in the Bible? I think that's a huge problem for theistic evolutionists who reject the existence of Adam. Okay? Because you got to pick a starting point somewhere. Another problem is Jesus actually believed that Adam was a real person. In Mark 10, 6 and 9, it says, "But from the beginning of creation, God made them male and female." He's talking about Adam and Eve. "Therefore a man shall leave his father and mother and hold fast to his wife, and the two shall become one flesh." So listen, Jesus, and this is huge, because if you're going to say that Adam wasn't a real person, now you're saying that Jesus held a false belief. Jesus just was believing the mythology of his day, okay? And I think that's got huge issues as well. But here's where things get really bad, okay? Without a historical Adam, there's no historical fall. And without a historical fall, there's really no original sin. And if there's no original sin, then who needs a redeemer? Right? If I don't have a sin problem, then I don't need a redeemer. Okay? And so this has, I think, like gospel implication. Like you literally, Lamoureux says, no impact. No, this has huge impact. You undermine the gospel, I think. So what does a guy like Giberson think the original sin is? Well, if you read his book, he'll tell you. He says selfishness drives the evolutionary process. Unselfish creatures died, and their unselfish genes perished with them. Selfish creatures who attended to their own needs for food, power, and sex flourished and passed these genes to their offspring. After many generations, selfishness was so fully programmed into our genomes that it was a significant part of what we now call human nature. So you want to know where sin nature comes from? It was always there. It's been happening since the very beginning, when that first selfish single-celled organism was fighting with that other single-celled organism for food. But does that sound like the Bible to you? Does that sound like Genesis? Well, Paul doesn't think so. Okay? Paul doesn't think so. Like, where did sin come from? You got Giberson saying, well, it's just selfishness. It's always existed. But Paul says, you want to know where sin came from? He tells us. We don't have to guess. Romans 5:12 says, therefore, just as sin came into the world, it came into the world. When? He tells us. Through one man. How did it come into the world? Through one man. And death through sin. And so death spread to all men because of all sin. And that's why there's death in the world, by the way. And depending on where you're coming from, you're either going to take this to mean human death, or some take it to mean all death, including animals. Okay? But Paul goes on even further from there. He says, yet, death reigned from Adam to Moses. It seems like Paul thinks Adam's a real person, just like he thought Moses was a real person. Imagine if I said, yeah, death reigned from Santa to Moses. Is there any problem with that? From the Easter Bunny all the way to Moses. That makes no sense, okay? From Adam, a real person, to Moses, even over those whose sinning was not like the transgression of Adam, again, he mentions Adam, who was a type of the one who was to come. Man, I got 5 minutes. Okay, listen to Paul's argument here. This is real, I actually skipped over Romans 5, 15, 17, he makes an argument, an if, much more. Don's preached on this before, so you can see the sermons if you go back into the archives. But listen, the if and the much more, they go together. And if you get rid of the if, which is the Adam part, wrong, then the much more just kind of falls apart. The argument falls apart. But here's Romans 18, 9 and 19. It says, therefore, as one trespass, this is Paul speaking. These guys have to say that Paul didn't know what he was talking about. Okay? Paul, under the inspiration of the Holy Spirit, had no idea what he was talking about. That doesn't jive with me. In fact, guys like, I don't know about Giberson, but Peter Enns, who was at Biologos for a long time, he actually denies inerrancy. And you can see how that would just fall out from this. How can you hold that the Bible is true when it has mistakes like this? Paul says, therefore, just as one trespass led to the condemnation of all men. One trespass, who was that? That was Adam. Condemnation of all men. So one act of righteousness leads to the justification of life for all men. For as by the one man's disobedience, who was that? Yeah. The many were made sinners. We know the many here means all. Everyone's a sinner as a result. That's how sin came into the world. Remember, Romans 5:12. Came into the world through one man's disobedience. So by one man's obedience, Christ's obedience, the many will be made righteous. You see how that just flows together? And if you kick out the foundation of a historical Adam, well, then this whole argument falls apart. And so I think there's a serious problem if you accept the theistic evolution view. Notice the argument is all about the overthrow of one sin of the one man Adam by the salvation of the one man Christ. So listen, a metaphorical Adam and a metaphorical fall, they would not require a historical atonement. Okay? A mythical atonement would be required for a mythical fall. Okay? And so, so here's just an illustration that I want to close with. Imagine a young boy sits on his grandpa's knee, and he looks at his grandfather's face, and he sees this large scar across his cheek. And this gets the boy's attention, and he says, "Grandpa, how'd you get that huge scar on your face?" And he says, the grandfather replies, "Well, once upon a time, in a faraway land." Whoa, wait a second, Grandpa. I don't think you understood what I was asking you. I was asking you how you got that real scar on your face. He doesn't want a story. He wants to know how he really got that scar. And listen, we all know from experience that there is a scar. We know that things are broken in this world. I mean, just search your own heart and you will know that there's evidence of the fall, a sinful nature. And I think we do a huge disservice by getting rid of a historical Adam because we undermine the whole reason why we have the sinful nature to begin with. And so we need to, I think, we need to be fighting for this. This is one of these issues that I personally am going to die on this hill. You know, a historical Adam is where I'll plant my feet because this is huge. You get rid of this and you undermine the gospel and the reason we need a Redeemer. And so, that is, I think, an insurmountable theological problem faced by trying to harmonize evolution and Christianity. These theistic evolutionists, listen, and we said this before, I don't think they're all bad guys. I'm not trying to attack them personally. I think they're trying to keep respectability to Christianity and the gospel. But in the process, they don't even realize that they've undermined the whole thing. And so they've actually destroyed the gospel that they're trying to advance. And so the question is: should Christians embrace evolution? My answer is, the short answer is no. Why do we have 3 classes for this? How could you say that? So listen, that clock's wrong. I got a minute for questions. Does anyone have a question? If you don't, I hope you don't. because I don't have time to answer it. So you can just give me a whole bunch of cues, no A's, no answers. I just want to say thank you for having me the last, it's been like 6 weeks. I mean, the Christmas holiday's been there, but it's been a blast in here. So I'm going to miss you guys, big time. I'm going to be crying tonight. I'm going to miss you guys, but I'll be around, and I'm sure Don will ask me to step in next year, or 2 years from now. I don't know, maybe he's a theistic evolutionist, and I'm not going to get invited back.
You know what, that was an awful lot of work. Hey, let's just thank him. How blessed I feel we are to have teachers like this with a high degree of design specificness of their imagination, not grow on trees, if you know what I mean. And we're very blessed at the kind of people we have in our church. So don't forget about Josh. He'll do it. It'll be totally different, and it'll be equally good, and you'll enjoy it. That'll start next week. He'll be for the month of February. And then we'll get back. Rich will be coming back. Frank's going to be coming back. Ken's going to be coming back. They can't go anywhere. They're signed up here as long as I'm here. They have to stay. When I resign, they're all free to go wherever they want. That's a good deal, eh? God bless you. Thank you.
All right, you guys dismissed.
It'll be a little warmer, so that's nice.
That's what I think. But you never know, right? All be very different. So I don't know whether that's his expertise.
What the textbook argument is that we evolved from something like a hominid, okay? And so this hominid, that red dot there that you don't actually see a picture of, you're going to have chimpanzees breaking off one way and then eventually you get human beings, okay? And that's why there's still apes around on the theory, okay? So there's a couple of bad arguments. I could probably do a whole thing on bad arguments, but those two just came to my mind. You hear quite a bit. So now that we've critiqued evolution, what I want to do is give a positive argument for design. So, there is good reasons to believe that God supernaturally created. In fact, in Genesis it says, "Let there be, let there be, let there be," and it was so. Okay, God creates by fiat or divine decree. Okay, and so it turns out that most people actually will agree with you that things appear designed. Okay? You don't have to necessarily push them to argue that there is at least appearance of design. Professor Richard Lewontin, he's a Harvard geneticist, he said that living things appear to have been carefully and artfully designed. Richard Dawkins, of all people, page 1 of The Blind Watchmaker, says, biology is the study of complex things that appear to have been designed for a purpose. Richard Dawkins agrees there is at least appearance of design. I already quoted from Francisco Ayala. In the first part there, he says, the functional design of organisms and their features would seem to argue for the existence of a designer. Okay? It seems that way. And so what is it about this appearance? Well, and I also showed you this slide. I thought I'd just revisit this. Remember, the atheist says appears designed, not really designed. The theistic evolutionist, strangely enough, says that things appear undesigned, and that's why they argue junk DNA, pseudogenes, those kinds of things. But they really are designed, and I said that kind of they're both right. The Apostle Paul makes the argument that they appear designed because they really are designed. For since the creation of the world, God's invisible qualities, his eternal power, divine nature, have been clearly seen, pure design, being understood by what has been made, because they really are designed. And so here's a little illustration to kind of help with this whole thing. The difference between real design and apparent design. So here are 4 different kind of rock formations. Group 1. If you drive across the Black Hills of South Dakota, you're going to come across this particular formation. What's it called? Mount Rushmore, okay? And this is carved into the mountain is the likeness of 4 U.S. presidents. No one would argue that that is not the product of intelligence, okay? It's of transitional forms in the fossil record, okay? And Darwin said that was one of the gravest objections against his own theory, was that there just isn't these fossils. But he said, wait and see, we'll find them. And here we are, 150 years later, and we just don't have all of those fossils. What else? Vestigial organs, non-functional structures. Specifically, I looked at pseudogenes, and we said, and Francis Collins, he thinks that's a very persuasive argument. Chimpanzee has the gulo pseudogene, the broken gene for synthesizing vitamin C. Humans have it. So look, aren't we related? Isn't this strong evidence that apes and humans have a common ancestor that broke the gene? And I said, yeah, but if you look over here, guinea pigs have the exact same gene that is broken, okay? So we talked about pseudogenes and vestigial organs. Just because something is non-functional now doesn't mean that it wasn't designed before. We know it had a function. Everyone agrees it had a function. And so why couldn't we just say that it was created with a function and then soon went non-functional? Kind of like the screen going non-functional on us here. Another powerful argument is homology, and that is you look at all these structures, and they seem to be the same, and like the whale flipper and the bat wing and the human hand, and all of those structures, even though different function, the structures are very similar. And so maybe that points to a common ancestor. Listen, that's a pretty powerful argument. I readily agree that that's a pretty powerful argument. And I didn't stress this enough. They say that's common descent. That's because those all come from a common ancestor. But that also could be common design, right? Like, it's not just common descent is the only option. There's this idea, it's a common designer who made all of those things, so why can't we say that, the guy who designed the Porsche is also the guy who designed the Volkswagen Beetle? And if you look at the similar mid-rear engine and some of those other features, they're the same. And the reason they're the same is because of the common designer. Okay? And then I talked about junk DNA. Oh, we're back on. Perfect. Can I get that one on too? Junk DNA. There's all this junk in our DNA. And I said that it's not really junk. In fact, we know it's regular. Let me start by praying, and then we'll do some fellowship, and then we'll get into this. All right, my wife is here, so now I can begin. Didn't mean to embarrass you. Heavenly Father, we thank you for this opportunity where we can come together in this place. God, I just pray your special blessing over all the teachers and volunteers who are volunteering their time tonight to just serve your kingdom, God. And so we pray a blessing over them. God, right now I pray that by the time we finish this tonight, we'll be closer to truth than when we started. And so, God, I pray that you just give us minds to think through this clearly. I pray that you would make my words articulate so that everyone can understand. I pray all this in your name. Amen. So let's begin by doing a little review. Who remembers what we talked about last week? We looked at a number of the evidences offered in favor of the theory of evolution. Can anyone recall one of those evidences? Just yell it out. Wow. Something about DNA? You guys need my help. You guys need a lifeline. You're gonna phone a friend. What? Finch beaks? That was actually 2 weeks ago. All right, I'm gonna help you. No, fossils? Yeah, we talked about the fossil record. Specifically, we looked at the Cambrian explosion. Remember all of those animal body plans that just kind of show up in that particular rock layer, the Cambrian rock layer. And we said there really isn't any evidence of missing links or transitional forms to lead up to that. But we did talk about dinosaurs in the Q&A, and that was fun. Yeah. Yeah, we talked about Richard Lenski's experiment, which is essentially, it's not a computer program, it's like the real deal. He's studying E. coli bacteria. He's looking at, started in 1988, and it's still going on today, but as of 2010, he had 50,000 generations of E. coli bacteria. 50,000 generations. If you made that equivalent to human generations, it would be about 1 million years worth of evolution. Okay? And we said that in that length of time, in that number of generations, 50,000 generations, he saw that they could metabolize citrate, but we said they could do it anyways. It didn't actually evolve that ability. Essentially, a transporter broke so that it was on all the time, like the nightlight being on all the time. And so they also got bigger, and we said they lost their flagellum, their tail, and that is supposed to be, the proof of evolution. I said, that's de-evolution. That's not going to get you where you need to go. So that was Lenski's experiment. That's an important thing to know, I think, in this whole discussion. In fact, someone emailed me and said, I was watching this video online and people were debating back and forth, and I don't like to get into those things because they don't usually go anywhere, but especially on YouTube. But someone brought up Lenski's experiment, and they said now they knew what the person was talking about. What else? Embryology. That was, Darwin said that was second to none in importance. He said that it was the strongest evidence in favor of his theory. It's still in the textbooks, but I showed that actually it's not true. In fact, Ernst Haeckel fraudulently drew these diagrams. They don't actually look anything like that. And they talk about the tail. We looked at all that. In fact, that was on the University of Berkeley website. They have an Evolution 101 site, and it was still on there. The embryos, it had the gill slits, and there was a whole blurb about how that was us kind of recapitulating our fish stage, of our evolution. So, ontogeny, although I watched the video, I said ontology, that's the study of being. That's what philosophers like to talk about. Actually, I'm taking a class called metaphysics, and we're getting into that. Ontogeny is this development from embryo to adult form. Okay, so ontogeny recapitulates phylogeny, is what the catchphrase. Know that for parties. Anything else? What else have we looked at? We looked at with the fossils, whale evolution, and I didn't critique all the different transitions. I said it has to happen in a very short amount of time. Even if it is millions of years, it's still too short to get all that needs to be accomplished done. The tetrapod evolution, I said they basically have to start all over with that since they found these fossil tracks. Yeah. Coelacanth, yeah, stasis. When you look at the fossil record, it seems like there's more stasis than actual evolution. Things remain the same for millions of years. And there should be billion things. And the ENCODE project in 2010 came out with all this information showing that, hey, this is not junk. It doesn't code for proteins, but it is doing something. So let's get into this. I've stalled long enough. So here's a couple of things you need to know. Bad arguments. Don't use, there's some arguments that we should not be using, okay? And I had to throw these in because I don't want you using them. Okay, so please, if you're talking with someone who holds to the theory of evolution, don't tell them that evolution is only a theory, okay? If you're talking to an intelligent person, they will chew you up and spit you out, okay? Because the theory of evolution, or a theory, is a set of beliefs, but it's a set of beliefs that has been verified or repeated or tested. It has a lot of evidence to back it up. That's how science defines theory. Now, so you have things like cell theory, atomic theory, the theory of relativity, or general relativity, gravitational theory, the theory of evolution. Now, they're all considered scientific theories. Now, we can argue or debate whether it should be classified as a theory, but the fact that most people accept it as a theory, don't use this, it's only a theory. Because what they'll say is, and there's a bumper sticker, yeah, evolution's only a theory, kind of like gravity, right? And does anyone really want to question? Does anyone want to say, well, gravity is really only a theory? Or heliocentrism is only a theory? We don't want to use that argument, okay? So just avoid that. Another argument is, bad argument, is if we evolved from apes, why are there still apes? Right? It may sound like a reasonable question, but if you understand evolution, it's really not reasonable. If an evolutionist should respond like this, and I don't know if you can see it on there, if God made man from the dust of the earth, why is there still dust? Right? And their response would be, well, you didn't use all the dust, right? And put that into Adam. Just like they don't believe that all the ape-like ancestors evolved into humans. A group broke off, okay? Think of the tree, broke off from to one branch and evolved into humans. And that's why there's still apes, okay? And so don't ask them, and someone thought it was clever at this Baptist church to put that on the sign, and they just look like idiots. So you have something like, you have like this tree, right? And what